Our second theme of statistics is data production. When answering a question where the data come from is important. Data beat personal experiences. In other words, you can't say, well, everybody drinks at Forest Lake because you go to a party and the people there are drinking or at least seem to be drinking. So you can't use everybody knows or everybody says. No, it's not acceptable. Data sources that are available, you can say what data is available. You can take surveys, observational studies, and experiments. Well, available data, let's say, for example, we want to find the average height of the female students here at Forest Lake. Well, available data, I might say call up Coach Wagner and ask her for the list of her roster of her girls basketball players. That's available to me. A survey, well, I've used this example before, but it's kind of like our Most of Us survey. Observational studies, well, that's you sit and observe things happening. So let's say you want to observe how many students are tardy to class. So you sit at the entrance to the building and count how many students that come in tardy. Experiments, and this is just like what you've done in science class, where you apply treatments or you change things to see if that affects or doesn't. Probability is our third theme. Long-term chances of an event occurring. And that's the key here is that it's a long-term. Just like if you have a deck of cards and you pull one card out and it's ace of hearts, that doesn't mean it's 100% guarantee to get an ace of hearts every time. It's unpredictable in the short run, meaning you don't really know how many times you might get the jack of spades out of a deck. But if you did it over and over and over and over again, it'd be 1 out of 52. Same thing with flipping a coin. You can flip a coin, say, 4 times and get 3 heads. Does that mean it's a unfair coin? Or is 4 times really enough? When we use probability in this particular case, it's to determine how likely certain sample values are. Is this value likely to be due to chance? Here's an example that I'll use. Let's say I claim to be a 90% free throw shooter, and I shoot 10 baskets, and I make 8 of them. Now, is that 8 enough to say I'm not a 90% free throw shooter? What are the chances that I made 8 out of 10 if I'm really not a 90% free throw shooter? When we deal with statistical thinking, data come from real world contexts. Doing statistics means more than just manipulating data. As a matter of fact, that step's pretty easy because we use our calculator to manipulate it. Form the habit of asking, what do the data tell me? This is the challenging part. When we work in statistics, students ask me, is stats hard? And I said, well, it's easy to do okay because the math isn't difficult. You use your calculator. And then I tell them it's hard to do really well because we have to think about what the this stuff means. We have to do. And we'll be doing quite a bit of labs and other practice.